Hello, welcome all. Myself Kiran. I am from Department of ISP SPC. Today we will learn about mergesort. First, let us see the outline. Definition, overview, how the mergesort works, pseudocode, and the tracing, which is the most important part. The time complexity, application, advantages, and the drawbacks. First, let us see what is meant by mergesort. Mergesort is a popular sorting technique that employs divide and conquer strategy to sort the elements. How it works? It divides the array into smaller subarrays and repeatedly divides it until we get the size of the subarray as 1. And once we get the size of the subarray as 1, and then we sort the subarrays and then we merge them. And let us see in the further slides how it works actually. And let us see some overview. Merge sort algorithm can be summarized in the following steps. That is, it employs three steps: divide, conquer, and merge. In the divide step, we divide the array into smaller subarrays and repeatedly divide it into smaller subarrays until we get the size of the subarray as 1. And in the conquer step, once we get the size of the subarray as 1, we sort them. And in the merge step, once we get the uh, size of once we get the sorted subarray, we merge them. And let us see how it works. Let us consider an array of 4 elements, and these elements are 38, 27, 43, and 10. First step is we we divide it into left subarray and the right subarray. That is, left subarray consists of 2 elements, 38 and 27. The right subarray consists of 2 elements, 43 and 10. And in the step 2, these subarrays are further divided into 2 equal halves. Now they become an array of unit length that can no longer be divided, and the array of unit length are always sorted. That is, we have reached the base condition. Once we divide the left subarray and right subarray here, and once we have reached the base condition, we we sort them and we merge them simultaneously. And in the fourth step, we combine the left subarray and the sorted left subarray and the sorted right subarray to get the new array, that is sorted element. And let us see the pseudocode. And let us consider a function with the name mergesort, which accepts the three arguments a, l, and I. A, l, and h. A stands for array, l stands for low, and h stands for high. And return if l is greater than I, return. That is, we exit out of the function once we reach the base condition. This is the base condition. How we reach this base condition? Once we when we divide the array recursively uh, with the help of the two functions, that is merge sort of a comma l comma h and merge sort of a comma l plus 1 comma h. And once we get the base condition, then we merge with the help of a function, with the help of merge function, which accepts the four arguments a, l, mid, and high. And see the next let us see that tracing, how the divide works. Let us consider an array with 6 elements, with low as 0, high as 5. Once First we should find the mid value, that is low plus high by 2, 0 plus 5 by 2, that is 2.5. We should consider the floor division. So mid value is 2. And once we get the mid value, we can divide the array into left subarray and right subarray. And the limits of the left subarray is 0 to mid, and the limits of the right subarray is mid plus 1 to high. So the limit of the left subarray is L is 0 and the high is 2, and the L is 3 and H is 5. And let's consider the left subarray with the limits 0 and 2. We get the mid value as 1, and since we get the mid value as 1, its limits are 0 to 1, that is left subarray is 0 to 1, and the right subarray is 1 plus 1, that is 2 to 2. So I written L is equal to 0, H is equal to 1, and L is equal to H is equal to 2. And here we can see that we have reached the base condition. And let us divide the left subarray 6 2 into further subarray. We get the base condition. We should follow this step for the right subarray to get the base condition, that is the size of the subarray becomes 1. And let us see the pseudocode, how the division uh, occurs. First, let us find the length of the uh, sorted. First, let us find the length of the sorted left subarray and the length of the sorted right subarray, and we'll be storing that in the n and nl and nr respectively. And let us consider I j k as 0. I is an index that is pointing to the left subarray, j is an index pointing to the right subarray, and k is an index pointing to the uh, new array where we store the sorted elements. And and here I had given while loop. This loop will run until I and j reaches the last index of the left sorted left subarray and sorted right subarray. And I had given the condition: if L of I is less than R of j, that is, if we get an uh, element at the left subarray is less than element at right subarray, we are going to copy that left subarray into the sorted into the new array, and will increment j and k. If suppose if the element at right subarray is greater is less than the element at the left subarray, we are going to copy that element from the right subarray into the new array A. We are going to increment j and k. We are incrementing the k because if we don't increment the k, all the whatsoever the element that is coming from the left subarray and the right subarray will be copied to the same position, and the values are overwritten. We will not going to get the sorted elements, or we will not going to get the sorted array. And we are incrementing I and j only because we are not interested to compare the same elements again and again. And let us come to the second and third while loop, where suppose if the left subarray get exhausted, we are going to copy the right subarray to the new that is we'll going to copy the right subarray into the new array A. And suppose if the right subarray got exhausted, we are going to copy the left subarray as it is to the new array A to get the sorted list. Let us see the tracing. First, we get the left subarray 2, 6, 11, and the right subarray 4, 5, 7, where I and we will be pointing I to the left subarray, that is first index or zeroth index of the left subarray, that is 2, and j will be pointing to the 4, and k will be pointing to the new array. And we are going to compare first element of the left subarray and first element of right subarray. Since 2 is less than 4, we are going to copy the 2 to the we are going to copy the 2 to the new array A, and we will increment I and k. We are not going to increment the j. Okay, see what I told, it's written there, it's written here. We are going to increment k and we are going to increment I, and we are going to compare 6 and 4. Since 4 is less than 6, we are going to copy that 4 to the new array A, and we are going to increment the j, and we are going to increment the k. And we are going to compare the 6 and 5, that is 5 is less than 6, we are going to copy the 5 to the new array, and we are going to increment the j, we are going to increment the k. We are incrementing the j because we are not interested to compare 5 again with the 6. So we are incrementing the j, and we are incrementing the k because if we don't increment the k, the value in the next iteration, the value that what it comes, it will be overwritten in the 0 1 check in the 0 1 second position of this array, which is not desirable. So we are going to increment the k, that is we are in order to avoid overwriting the values in the same index. And 6 is less than 7, so we are going to copy the 6 to the new array A, and we are going to increment k and I respectively. And in step 5, we are going to compare j and I, and 7 is less than we are going to compare 7 and 11. 7 is less than 11, we are going to copy 7 to the new array, and we are going to increment the j, and we are going to increment the k. And as we have seen that right sub array got exhausted, so we are going to copy 11 as it is, and then we are going to increment the k. This is how the merge sort works and the merge works. And as we increment k I j, we all this got exhausted, we'll get the sorted array like this. And this is how This is, let us see the overall procedure. That is, we divide the first we divide that into smaller subbase and we'll get the base condition. And as we can see that 6, 2, 11, 7, 5, 4, these are the base conditions where we are getting only one sub array. And and we merge them to get a sorted array. And it is a time complexity. The time complexity of the merge sort is big O of n log n. And and uh, the time complexity is given by t of n is equal to 2 into t of n by 2 plus omega of n. N by 2 is written because we are dividing the array into two equal halves. So I written n by 2, and 2 I written because we are getting two equal halves. And the worst case, average case, and the best case time complexity of the uh, merge sort mm, is big O of n log n. And this equation is according to Master's theorem. We will look in the further slides. And the Master's theorem says t of n is equal to a into t of n by b plus f of n, where f of n can be n is n comma n square comma n also. And d should be greater than or equal to 0. And the order of growth of t of n depends on the values of the constants a, b, and function f of n. In the Master's theorem, we consider three conditions. That is, when three cases: if a is equal to b power d, then t of n is equal to big O of n power d log n. And if in the case 2, if a is less than b power d, we should consider big O of n power d. And if the a is greater than b power d, that is the case 3, to consider n big O of n power log a to the base b. And the merge sort falls under big O of n power d in this Master's theorem. And that is the case 2. And application: the application of merge sort is it, it can handle very large set of inputs, and it can sort the data sets very efficiently. And it can sort the partially sorted arrays, uh, nearly sorted or completely sorted array. And advantages is it can efficiently sort large data sets, and it employs divide and conquer strategy. And most important is it can sort the elements with fewer comparisons and performs well in various input scenarios. And the drawbacks is uh, it uses extra memory. It uses extra memory, that is, as we see, uh, to get the merge array, it has used extra memory. And it's slower for smaller data sets. And not in place algorithm means merge sort, it requires extra memory to sort the elements. These are some of the drawbacks, and I hope you enjoy the session. If you have any doubts, you can comment in the comment box. Thank you.